One of the harder, often misunderstood primitives within JavaScript is the number data type. So in this tutorial, not only will we look at the basics of number, but also its limitations, some special numbers, fancy modern syntax, and lots more. So by the end, you will have complete mastery of this critical data type. So let's go. The number data type within JavaScript is a 64-bit signed floating value. This means that it can be used to represent integers as well as decimals as well as negative numbers. Now make no mistake, they are the same data type, so 1337 will be exactly equal to 1337.0000 if you wanted to do that comparison. Modern JavaScript numbers can also include an underscore, and this is purely for readability purposes. This does not impact the value that is contained by that number. Additionally, you can declare numbers with the scientific E notation. After the E, you are basically specifying how many times you want the decimal to move towards the right. Here, of course, we are saying that starting with the value of 1, we want the decimal to move 6 times towards the right, giving us 1 followed by 6 zeros, which is a million. We can actually provide a negative value after E as well, and that will move the decimal point towards the left. So here we are saying that starting with 1, move it 6 times towards the left, giving us 0.5 zeros and 1. Similar to other primitive types, the type of operator also works with numbers, and when you apply it to a number value, it returns the string number. Now the number data type within JavaScript is a true binary floating point value, which means that they suffer from the binary floating point error that you might be familiar with in other programming languages. If by any chance this is the first time that you are experiencing this, you can actually visit this website to learn more about this fact. But in short, it exists in most programming languages, including Java, C, and C++. As you would expect, JavaScript numbers support all the common mathematical operators. You can use the plus operator to add two numbers, for example 1 plus 1 is 2. You can use the minus operator to subtract one value from another, for example 5 minus 1 is 4. You can use star for multiplication, for example 5 star 2 is 10. You can use the forward slash for division, for example 10 divided by 4 gives us 2.5. You can use the % sign for remainder, also called modulo. So 3 divided by 2 gives us a remainder of 1, and 6 is a perfect factor of 3, so that gives us a remainder of 0. JavaScript also has the exponent operator, which you might be familiar with as power, and it is represented by double stars. For example, 2 to the power 3 gives us 8. Now with these mathematical operators, there is also a concept of shorthand assignment. As an example, consider a simple variable which we have initialized to 1, 2, 3. We can do a mathematical operation, for example +1, and then assign the value back to the original variable. Now of course this does work because 1, 2, 3 plus 1 is 1, 2, 4. However, there is a shorthand syntax for this particular statement. We can do the same thing with plus equal 1, and what this does is actually takes the variable, adds 1 to it, and assigns it back to the variable. As far as the runtime behavior is concerned, these two statements are perfectly equivalent. And of course, this shorthand version exists for all the other mathematical operators that we've seen as well. For example, 123 minus 55 gives us 68. 123 star 2 gives us 246. 123 divided by 2 gives us 61.5. 5 divided by 2 gives us a remainder of 1. 16 to the power of 0.5, that is the square root of 16, gives us the value 4. Just like other C-inspired programming languages, JavaScript also has the double plus and the double minus operators along with their prefix and postfix support. So you can take a variable and add plus plus after the variable or plus plus before the variable, and both of these will increment the variable. For example, we start with 0, we go to 1, and then we go to 2, and the same is true for minus minus as well. We can do example minus minus to get minus 1 or minus minus example to get minus 2. The difference between the postfix version and the prefix version becomes obvious when we try to do the same within an assignment expression. Here we have the same code written twice, but the first time we are using the postfix ++, and in the second example we are using the prefix ++. To understand the difference, focus on the terms post and pre. With post ++, the runtime returns the current value immediately, and post that we update the value of the variable. So the value that goes into the result is the original value, which is 0, and then example gets updated to the value of 1. Similarly with pre++, the value gets pre-updated, so example is immediately going to become 1, and that is what is returned into the result. And the same thing applies to the minus minus postfix and prefix operators. With postfix, the result is going to be the value before the update, And with prefix, the result is going to be the value with the minus minus pre-applied. Now it shouldn't come as a surprise that these operators only work on variables that can be mutated. For example, alpha is a let variable and therefore alpha plus plus is perfectly fine. However, if you just have 3 standing by itself, it's not actually a variable, so 3 plus plus is going to result in an error. And similarly, if we have const beta, then beta is a const and therefore it cannot be reassigned and beta plus plus will not be allowed. And of course, if you have TypeScript configured as we did in a previous lesson, then it'll catch these silly mistakes for you at compile time. To make code execution decisions based on a value, we need to be able to compare numbers, and of course, JavaScript comparison operators have got your back. You can compare two numbers with a less than operator, and of course, 1 is less than 3, so that's true. You can use the greater than operator. 1 is not greater than 3, and therefore that is false. There is also less than or equal to. For example, 3 is less than or equal to 3 because it is equal to 3, and that will be true. There is greater than or equal, and 4 is not greater than or equal to 5, which is actually less than 5, so therefore it will be false. And there is also strict equality. For example, 1 is equal to 1, and of course that's going to be true. And strict inequality, which is not equal, so 5 is not equal to 3, and therefore that is true. Because JavaScript numbers have a fixed bit size of 64, there are limitations on the size of integers that it can safely represent. There is a global number module that has this member called max safe integer, which represents the max safe positive value, and similarly there is a min safe integer which represents the minimum safe value. Now, safe in this context refers to the fact that the value cannot be the result of a rounding error. The unsafe values are +1 away from max safe and -1 away from min safe, and what that basically means is that there is no guarantee that the result that we get at this point is not the result of a rounding error. So max safe +1, while correct, is ambiguous because +2 will give us the same value. So max safe and min safe, you are perfectly fine. Outside of that range, numbers can be represented, but there might be a chance that they might have been rounded. Now to check if there is a chance that a rounding might have occurred on the value, you can use this function called numberIsSafeInteger, and of course max safe integer is safe, but anything else outside of that range is not going to be safe. For example, +1 is not going to be safe, and similarly any other number that we write that is going to be outside that range is not going to be safe. If you go out of bounds of what values can be represented in the 64 bits, you will end with infinity, which is still a well-defined numeric value within JavaScript. As an example, if you decide that you have had enough and raise 10 to the power 1000, you will get infinity, and if you multiply it with -1, you will get minus infinity. Dividing a positive number by 0 will give you infinity, and dividing a negative number by 0 will give you negative infinity. Now, as I mentioned, these are well-defined literals, so you can actually type it in yourself as well, and it is equal to itself. So infinity is equal to infinity, minus infinity is equal to minus infinity, and they work with comparison operators as well. So infinity is greater than any other positive number that you can think of, and minus infinity is smaller than any other negative number that you can think of. Now these values also exist as members of the number module. So number has positive infinity, which is of course equal to infinity, and negative infinity, which is of course equal to minus infinity. Since the origin of JavaScript lies in user interface programming, working with strings is often required, and so the interop between numbers and strings is quite well built within JavaScript. Let's first look at converting a number into a string. Now numbers have a method called toString, which can be used to convert the number into a string, and this actually gets invoked automatically when we add a number to a string, and we've seen examples of that in our string lesson. When we are working with floating point values, we might want to format it a bit further because the default toString might give us a really long string that we might not like. For a bit of formatting control, there is a function built into strings called toFixed, which takes the number of decimal points that we want to display. So if we invoke toFixed on change and pass in a value of 2, we get back a string that contains 2 decimal digits. Additionally, toFixed will also round a value, so as an example, if we invoke toFixed 1, it rounds it up to 4. Now toFixed will always try to add the required number of digits, so if we don't have any, for example 42 clearly doesn't, it will add zeros instead. Now let's talk about the opposite, where we take a string and we try to parse it into a number. JavaScript has a global function available for us called parseInt, which takes a string and tries to parse it into its integer equivalent. If the string in question has a decimal portion, that portion is completely ignored by parseInt, so 23.55, we only get back the number 23. Now if we do want to parse the value as a float, then JavaScript has another built-in function called parseFloat, which takes that string and parses it into a float, so 23.55 string gives us the numeric 23.55. Now just like we use the double bank to convert other values into true booleans, JavaScript has the unary plus operator that can be used to convert a string into their number equivalent. When I have a string that I trust is going to parse correctly, then this unary plus is normally what I would use. But what about the case when we have a string that is not going to parse correctly? For example, sugar, spice and everything nice, although excellent, is not a valid number. For these cases, JavaScript has a special numeric value called nan, which stands for not a number. Beyond parsing things that clearly cannot be a number, the nan literal also shows up in other scenarios, for example when we try to divide 0 by 0. There is a very peculiar but completely reasonable behavior observed within nans that is best explained with a simple example. Here we have two variables first and second, which are the result of parsing two different strings. Now both of these are going to be nan, but clearly alpha and beta are not equal to each other, therefore it makes reasonable sense that first should not be equal to second. And indeed, this is the case within JavaScript. However, this does mean that a nan is not equal to a nan. This poses a slight problem because if a nan is not equal to nan, then a nan equal to nan will be false. This will actually prevent us from checking if a particular value has resulted in a nan, but fortunately JavaScript has a very nice global function called isNan that will tell you if a particular numeric value is a nan or not. And as a side note, these silly mistakes of comparing directly with a nan instead of using the isNan function are caught as a compile time error by TypeScript. In addition to literals in the decimal number system, the number data type also allows us to express our ideas in other digital bases, but make no mistake, they are still backed by the same binary 64-bit value. Consider the simple integer 32, which is of course 2 to the power 5. Representing this value in binary should be 1 followed by 5 zeros, and we can actually write that literal within JavaScript with 0b followed by the binary value. Note that this is still the same number underneath, which is 32, which is of course why perfect is equivalent to this binary literal. In addition to binary, we can do octal with 0o, and this is 40 in octal, and hexadecimal with 0x, and this is 20 in hexadecimal. Now all of these notations are case insensitive as well, so it doesn't matter if b, o, or x are lowercase or uppercase. In addition to expressing ourselves in these numeric literals, we can actually take a numeric value and express it out as a string in any of these number systems. Now by default, toString will render it out in decimal, but toString actually optionally also takes in a base for the number system. For example, binary is base 2, and we get that 1 followed by 5 zeros, and similarly, octal is 8, we get 40, and hex is 16, and we get 20. And now that we know how to express these numbers as strings in different bases, we can actually parse them from the different bases as well. Now by default, parseInt will parse it as a decimal. However, we can pass in a second optional argument to parseInt for the base, for example, 2 for binary, 8 for octal, and 16 for hexadecimal. All of these strings in the different bases will parse to the numeric value of 32. JavaScript comes with a built-in global math module that provides a lot of utility functions and some constants that make it easier to work with numbers. For example, there is math.floor, which will get rid of the floating portion. There is math.ceil, which if there is a floating portion, it will bump up the integer value. So here 1.01 becomes 2. And then there is math.round, which will round it to the nearest integer most smartly. For example, 1.99 becomes 2, 1.01 becomes 1, and 1.5 gets rounded up to 2. And there is also math.random, which is perhaps my favorite function, and it returns a floating point starting from 0 but ending right before 1. And by combining this with multiplication and math.flow, we can actually scale it to whatever value that we want. For example, if you multiply it by 2, it is going to be in the range 0 to 1.99999, and therefore if you floor it, it is either going to be 0 or it is going to be 1. And similarly, if you want 6 distinct integers, multiply it by 6 and use math.flow to get 0 to 5. Math also has functions maths.max and maths.min, Max returns the maximum value within a set of numbers, and min returns the smallest value within a set of numbers. And these functions come in quite handy. And speaking of handy, math also has some constants. For example, math.pi, which comes in handy when you are working with circles. For example, here's the circumference of a unit circle. As you can see, there is a lot of power built into JavaScript numbers, and for most user interface programming purposes, you will be well looked after. As always, thank you for joining me, and I will see you in the next one.